Hello, my name is Andres Ferreyra. I'm an Industry Data Standards and Collaborations Lead in Syngenta. I also chair the International Organization for Standardization's new Technical Committee 347 on data-driven agri-food systems. And today I have the privilege of speaking with you about a topic that is very important to me and the TC 347 organization that has to do with data quality, specifically in this case, how to unlock hidden value uh, in data quality for agri-food systems worldwide. So let's start by acknowledging that um, agriculture and food production is getting progressively more difficult. This is traditionally a set of processes that involve hundreds of decisions per year. And those decisions are difficult and challenging for farmers and food producers of any size, but they're especially challenging for smallholders that are far more vulnerable to different kinds of problems. Now, in the past, these hundreds of decisions were typically driven by tradition, by what mom and dad had done in the farm before you, right? But now, increasingly, in the context of so much change, of rainfall that doesn't fall when it used to, or that all falls at once, or disruptions in supply chain and political unrest and so forth, these decisions must increasingly be made based on data in that context. And data is very important because it flows all over the, the agri-food system. In this simplification that we're seeing here on screen, imagine that large arrow as sort of the primary supply chain that goes from the, say, factory floor of the crop input manufacturer. So the organization that manufactures and sells the fertilizers and other chemicals or the seeds, all the way going from there to the supply chain that goes to the farmer, from there to the processor, and from there all the way to the consumer and their dinner plate. At each step, there's data exchanges, and each one of these actors in turn interacts with other actors like test labs and equipment manufacturers and advisors, and of course, regulators. And data is exchanged at each one of these steps. Now, I bring to you the idea that these exchanges are typically quite difficult, involve quite a bit of friction, and it's important for us to look for ways to reduce the friction there so that these processes can be scaled up and more value unlocked for different stakeholders from them. Yes. So another point that I want to make is that small producers, despite producing from 1/3 to 1/2 of the world's food, depending on who you ask, exist mostly outside the system of data exchanges. They stand to gain a lot from having more access to information and being able to market their products in innovative, data-driven ways. But currently, they have great difficulty doing that. So part of our challenge is to also see how this set of data exchanges can be made accessible to them. So, how to reduce friction? In the normal way, the baseline scenario, when you have somebody who is consuming data like that, let's imagine a grower here with this Z that we see there, trying to consume data from multiple sources like weather data from a provider, maybe some radar information from another one, um, maybe soil water data from sensors and data about what was done in the field, like as applied maps or things like that from machinery. They start realizing as they're trying to use this information that it's all in different formats, using different sets of codes to mean different things. It's all completely incompatible. And so somebody has to take on the burden of translating from that proprietary format that each one of these data sources has to a common format or a common data model that can be used by that data consumer. And that process of converting from each one of those languages, if you will, to the common one is very burdensome. It doesn't scale well. It's very painful. It's very painful. I can't emphasize this enough. I've spent a good fraction of my career working in that space, and I can tell you it's a valley of tears. What's the alternative? Well, using standards, using data standards for both the syntax of the data, so how we arrange the data, and then the semantics, so how we represent it and in code lists and things like that that represent its meaning. If we're using standards, then we don't have to do intermediate translations. Instead, the data producers make data available in that standard format, and then the data consumer knows to consume the data in that standard format. The burden of interoperability is spread evenly across the landscape, and creating data-driven tools is much easier than it is in the previous scenario. Okay, this is an important point, why we need standards. The problem, though, is that the industry is in a bit of a bind. Our standards aren't sufficient to support the data-driven decision-making needed to solve modern problems, including the Sustainable Development Goals like zero hunger and no poverty and so forth, right? And the reason why this happens is because both the industry and its standardization efforts have grown bottom up. So a small group gets together and does something, and if they're focused enough and work hard enough, it can turn into a standard, right? But when you're trying to do data exchanges across a vast set of industries, you need some coordination. So the International Organization for Standardization, ISO, realized this, and they chartered a strategic advisory group for smart farming that I had the honor of co-chairing. This was in mid-2021, and we produced our final report in early 2023. The mission was to develop a strategy that could guide this sort of hybrid top-down, bottom-up action. We produced a set of 49 recommendations that were very well received by ISO. And a key part of that strategy that we proposed was to create a place, an institution within ISO, where standards that were specific to this data-driven decision-making and enabling that data-driven decision-making at scale could live permanently. And this is now ISO Technical Committee 347 that I chair. Now, let's think about the kinds of data that we deal with and start tying this into concepts about data quality and so forth. So, and value. So imagine a tractor. It's going through a field pulling a planter. Planter's an implement that is performing a function and taking power and being moved around by that tractor. Tractors typically collect telemetry data, like where they are, how much fuel they're consuming, how hot their engine is, how many hours it has been running, and so forth. And they communicate this through the network um, that is the tractor itself, and make this information available to the outside world through a thing called the J1939 bus, which is essentially the same thing that you might have in your car or that's used in trucks or construction equipment. Now, the implement itself, if it's fairly new, uh, also collects data, but more like agronomic data as well. So things like the planting rate, like how many seeds is it putting in the ground per unit time or per unit area, um, or the depth at which it's planting and things of that sort, right? And it often reports that through a bus that is a sort of a superset of the J1939 bus called an isobus. Okay. And in any given situation where you're trying to extract data from one of these machines, you may have access to the isobus, or you might just have access to the J1939 bus. So if we think about uh, and let me give you a little hint here that has to do with the use case we'll be looking at. Tractors use a lot more fuel when they're planting than when they're not, right? Because a planter involves all these pieces of metal that when it's planting, they're stuck in the ground, moving the soil apart to make a furrow that then it puts the seed into, and then it closes it again after the seed. So there's a lot of mechanical movement and friction and so forth going on, right? Whereas if it's just bouncing around on top of the ground, it consumes less fuel. So let's imagine two problems that you're trying to solve with data, two different needs. So the first one is maybe you need to make an as planted map. So make a map over the field that shows how many seeds per unit area you put there. Doing variable rate planting, as it's called, is one of the strategies available to people that are practicing precision agriculture. So this is a valuable tool. The second need is determine something far more basic. It's determine if the implement is really planting. Okay. So saying like, is this thing really planting? Or do I have a good sense that it's really planting? Because in many parts of the world, it often happens that the operator of the tractor might be quite far, doing the work quite far from the landowner. And, there's that inclination to say, maybe I'll just drop the seeds on the top so that when they come by later, they'll see that there's some plants, but I won't do the whole thing. I won't plant them several centimeters deep. And instead, what I'll do is I'll save a lot of diesel and then I will steal it, right? So that happens. So imagine that you have two scenarios. One is where you have your full isobus data. So all of these things about what the implement is doing. And the other scenario is where you have just the J1939 telemetry only from the tractor. Okay. If you're trying to solve the first problem, let's look at the two problems and the two scenarios of data availability, and let's see what the fitness for use of the different data sets for creating those data products as the solutions to these problems really are. Well, if you have full isobus data, you can certainly make an as planted map. if the equipment is calibrated properly and so forth, you'll get a good as applied map from it, right? So the full isobus data set is fit for the use of making an as planted map. But the J1939 only data set won't be fit for use because it doesn't know, the tractor doesn't know, the bus on the tractor doesn't have signals flowing through it telling it what the rate of planting in the implement and its isobus are. So typically, by looking at J1939 data only, you're not going to be able to make an as-planted map. So this data set was fit for use. This data set was not. But if we're trying to make just a determination of if the implement is really planting, well, the full isobus can tell us that, right? Because we can see the planting rate and we can know if it's really putting those seeds out there and to what depth it's putting them and so forth. But with J1939, you might say, hey, wait, we don't have those planting rates available. True. But you know what we do have available? A signal that tells us about fuel consumption. And then if you know the nominal fuel consumption of this rig when it's planting versus when it's not planting, you can use fuel consumption as a very accurate proxy of what's going on in the field. So a J1939 data set might not be fit for use for this problem, to solve this problem, but it might be fit for use for this one. Okay? That's an important distinction that we'll return to in a moment. Okay, let's look at another problem. This one has to do with harvesting a crop. This harvester is a thing called a sort of mobile implement. It sort of includes the tractor and the implement all in one. It has a GPS unit which will produce accurate position data. Then it has some configuration numbers, you know, these X, Y, and Z axis offsets that show where the GPS unit is positioned with respect to a reference point on the machine and so forth. And you need to set many things in a combine, as these are called, in order for it to work correctly. But one thing that's very important in it is a thing called a yield monitor. This is a sensor that, you know, it has to operate under very harsh environmental conditions. So there's a lot of dust flying around, lots of heat, and so forth. So yield monitors are traditionally pretty simple. It's like a plate, a metal plate that has a spring on it, and then something that's sensing the position of the plate, and the position of the plate, which is getting hit by the incoming stream of grain that's being threshed in the front of the harvester. You know, if there's more grain coming in because the yield is higher per unit area, it'll push the plate in deeper. And if the yield is lower, it will push the plate in more shallowly, right? Now, this yield monitor must be calibrated fairly often to get accurate yield values. Okay, so and a reminder, you know, the yield is the mass that you're picking up per the area. So the yield can be thought of as something that you average for a whole field, or it can be something that you're looking at over time, thinking about maybe an imaginary rectangle of with a length of how much the harvester moved during 1 second, for example, and then a width of the header, the part that's taking in the grain, right? So let's imagine two problems again, where we have, on one hand, an accurate estimate of yield, okay, and on the other, just a harvested estimate of harvested area. You might want that for other purposes like insurance or for other reasons, right? So one is yield that involves mass and area, and the other is just area. And the available data here are the data stream coming off of the bus on this machine in a situation where the yield monitor has been calibrated well. And the other scenario is where it hasn't been calibrated well, which unfortunately is very common. So if we, again, think about fitness for use and start looking at the different combinations, again, if you have a well-calibrated yield monitor, you can get an accurate estimate of yield, right? Provided that everything else is also set correctly. And if you have a poorly calibrated yield monitor, you're not going to get an accurate estimate of yield. But looking at it the other way, again, we get that same pattern that we saw before, where yes, you can get an accurate estimate of harvested area if you got an accurate estimate of yield. But you can also get an accurate estimate of harvested area with a poorly calibrated yield monitor, right? So what's this got to do with data quality? Well, we can say that the data quality of, say, the poorly calibrated yield monitor was bad in the context, or insufficient in the context of where the data product that we're thinking of is an accurate estimate of yield in the field. But the data quality of the exact same data set was fine when we were trying to estimate harvested area, right? So let's go a little bit more formally. So data quality is characteristics of data that relate to their ability to satisfy stated requirements. And this is off of one of the ISO standards. I think ISO maybe 1444 or something like that, 14,044 life. And the question is, well, how do we state those requirements? Because it says we're trying to characterize data in terms of how it, of its ability to satisfy stated requirements. So how do we state the requirements? Through a document called the data product specification. And again, there's a nice standard called ISO 19131 that explains how to make those. Now, how does all this sort of fit together? Well, if we've got a data product like an as planted map, and we've got that data product specification, which we just mentioned, that specifies requirements for the data product and that the data product conforms to, but which also enables searching for and evaluating data products. We've got those two. We've got data sets that are included in the data product in some way, and such that the data product contains them or contains derived products from them, like in the case of, say, the yield map containing a derived product of the data set coming from the yield monitor and the data set coming from the GPS unit and so forth, right? Then data quality is part of what we call metadata, which is data that's used to describe data, like say a data set, right? Metadata describes a data set. Data quality also does. And data sets, it's a good practice that data sets include their metadata and include the data quality measures, as the variables that we use to measure data quality are called, right? And this metadata describes the data product and so forth. Okay, but basically, so we've got data product specification, data product, data sets, and data quality describes all of this, right? So now let's talk about an idea called a workflow, which is basically a sequence of how things are done in pursuit of a task. When we're trying to automate a process in whole or in part, so there might be some parts where there's people, some parts that are automatic, and then we've got electronic documents and information that are being passed from one step to another here, right? I want to make the point to you that many data quality problems, so many of these mismatches in fitness of use of data sets that are being collected in agriculture. And let me tell you, a lot of data is collected in agriculture, but unfortunately, most of it is not very fit for the uses that we would need to solve with those data. So I bring to you the idea that many of these data quality problems come from poor management of workflows. Okay, so let me give you some examples. Let's imagine that your goal is to place your seed products better. So you have some bags of different seed varieties that have different behaviors when faced with challenges like, say, a very wet spring or drought in the summer or high winds or things like that, right? So what kind of data product do you need to guide that? Well, among others, an as planted map, because you need to know what varieties you already have out there in order to be able to evaluate their performance, right? So a common workflow problem is that you just didn't identify the crop variety. It sounds silly, but it's very common, right? And that makes the as planted map not be so valuable. Another problem, you need to keep accurate pesticide application records, either because your regulator demands it from you, or your customers demand it from you, or whoever. So what do you need? Well, I need a work record, so a digital record of what was done from the sprayer implement. Like, what did I apply? Where did I apply it? When did I apply it? So that then people can know if they're within, restricted entry intervals, should stay away or what. Common workflow problem. Operators are not trained to identify the products being applied. So they don't do it. So they don't select a product. It's a common joke in one of the agricultural data standards implementation consortia that product one, which is often the default in these terminals, is the most commonly used product in the world, right? Because people just leave the default and move on, right? So lack of product identification means that after the fact you have to guess what it is that you applied and so forth, and that brings errors. A third one, also about keeping accurate pesticide records, right? Where you also need the same thing. Well, maybe you didn't send products and unique identifiers to the terminal on the tractor ahead of time, right? So the operator fails to identify the product properly, right? So it's not that they weren't trained to do it. It's maybe that it's not available. And so they start sort of punching in the name, and names of chemicals are hard to spell, and the whole thing is bouncing around, and they're busy. So this ambiguity in product identification then requires error-prone matching after the fact, right? Fourth example, let's say you want to check the accuracy of the invoices that your vendor of agricultural inputs gives you. This is a common occurrence that in the fog of war of the spring and early summer, retailers are stretched so thin that they will bill incorrectly, often billing twice for the same thing. And it's not even malicious. It's just too much chaos. And so you can check what you used with what you paid for, right? And then involve your inventory to make all these things match. And for that, you need work records from planters, sprayers, and spreaders, and so forth. But a common workflow problem is just if you just didn't properly identify the products, then you can't complete the mass balance or compare with invoices. So I just showed you four quite common problems. These four cases of lost value are just example of one workflow issue, right? Which is product identification. If we look at something more complex, like trying to understand if a field is making money or losing money, which even then is a relatively simple problem in digital agriculture, you're thinking about net income. And let's simplify that to say, well, this is my gross income minus my cost of production. Okay? So how much came in versus and minus how much came out. And let's keep the cost of production simple and not think about fixed costs right now and so forth, which are usually considered by the accountant more than the farm manager. Well, you can think of the net income as a total harvested crop times the price you got for it. So many kilograms that you got off of that field times the price per kilogram or per ton or what have you, minus the sum for all the applications of products that you had of the total amount of that product, be it irrigation water, be it a chemical or seeds or fertilizer or whatever, times the unit cost of that. So if you applied, say, 27 liters of a fungicide times the price of that of the liter, then you add all that up and you're done. So let's think about if you're trying to do this at the field level, you want to calculate that per field gross income, right? For that, you would need the per field total harvested crop, and you need the price per field's crop loads or a weighted average price for that whole crop. Let's imagine that you had 10 fields with corn. Well, you can either get the price that you got for the loads of that field, or you can average it out over your whole corn crop. That's fine. Those are two perfectly valid strategies. But the fact is that if you have a poorly calibrated yield monitor or an improperly identified crop, or you just lost your yield data, or you can't convert the data format, your yield data is going to be either unavailable or not trustworthy. So you're not going to be able to calculate this. And if you manage the scale tickets that you get from the grain elevator or your processor when you're selling vegetables or something like that, or your settlements with your processor, then the price you receive for the crop is uncertain. You deposited some checks or got some money in your pocket, but you don't really know what the exact price was. It happens. And looking at per field costs, again, you want the total amount of each input and you want the average unit cost of that input for that field, right? If you lost your application data set or you can't convert the data or you're relying on manual entry, right? Or you're not even measuring how much of that input you're using, like in the case of irrigation water without a flow meter, or your equipment isn't calibrated, your cost data is either going to be incomplete or can't be trusted because your mass balance is incomplete or can't be trusted, right? And but the cost data goes same as in the previous case, right? So you have a multitude of workflow problems, right? Each one of which can translate into data quality issues and fitness for use. Now, when you're dealing with data, there's a bigger picture. And there's a document called the Data Management Body of Knowledge, um, uh, produced by an organization called DAMA International, that um, that sort of lays out different dimensions of data governance, things you need to do to manage your data. So model your data, deal with storage, data security, and so forth. And one of the dimensions of that is data quality. And data quality itself has multiple dimensions as well. So accuracy, completeness, consistency, and so forth. In the interest of time, I'll just leave each one of these up for a few seconds. You'll get the slides afterward, and please refer to that more in depth there. And feel free to write me with comments and questions. But with accuracy, things that we've talked about, products not identified, sensors that aren't calibrated, or that are operating under suboptimal conditions, manual entry errors, so on and so forth. These will all affect accuracy. When you're missing operational data, or you have spatial and temporal gaps in sensors, when dealing with remote sensing and you've got clouds and so forth, your completeness is going to be a problem. Consistency, dealing with unit of measure inconsistencies, that is a problem. Agriculture has always thought of units of measure as an afterthought. It's very rare to find a data set that actually explicitly includes units of measure in it. Timeliness. When does the data arrive for me to use it? Late arrivals, which is pieces of data that show up into your API or whatever later than they were supposed to, perhaps after you have created a data product where they would have participated, are a daily occurrence in the space of dealing with digital agriculture. And these are all serious problems. Validity, uniqueness, an interesting case of uniqueness is a multipath problem, where maybe you have a machine that is collecting agronomic data like an as-applied map, and it reaches your system through the cloud of the manufacturer, but it might also reach your system because the operator brought a thumb drive with that information and imported it into your farm management information system. Or sometimes in the manufacturer's clouds, there's some process that happens to the data, some processing, and then it's cast again as a slightly different data set, and your software thinks it's a new one, right? Integrity, accessibility, credibility, interpretability, relevance, of course, and then your ability to know its lineage or to trace it. Okay, so why does this matter? Why do we care about this? Well, ultimately, there's a growing body of knowledge that shows that farms using accurate analytics driven by high quality data do better. They report higher yields, lower input costs, and significantly higher resource efficiency. In TC 347, we recently started a young professionals program. Most of the participants of which are from the African continent, in fact, and many of them are involved in programs that involve working with farmers to show them different aspects of regenerative agriculture and help them use data to make decisions about managing their soil and so forth. And these are the same kinds of numbers that they're looking at, right? So conservative estimates put the global value of this at over $100 billion annually, right? And very conservative estimates. So what can be done about this? Well, I propose a little framework of 9 points. And we don't have a lot of time to go through this, right? But these are pretty solid data management strategies that can be used to make these things happen. First, define clear data governance and stewardship. So appoint people who can help um, take care of the data and take responsibility for it. Standardize your processes for collecting data and metadata. Use standardized vocabularies and ontologies whenever you can. Apply controlled vocabularies for field names, units of measure, methods, products especially, and so forth, right? Monitor those multiple dimensions of data quality over time. Track them, right? Look for quality indicators with the data quality measures of the ISO 19157 standard. Be careful when integrating data from multiple sources and look at a great open source tool called Adapt as you do that, which might help you in your integration. Learn about what it means to make your data fair, which means findable, accessible, interoperable, and reusable. This link will give you the place to begin to understand how to manage your metadata, especially so that your data is more easily usable, okay, and interoperable and so forth. Of course, be careful with data security and use role-based access and encryption. Support continuous training. Think about that operator that we caught them doing things wrong so many times in the early parts of this webinar. Well, it's not their fault if they're not properly trained and the value of collecting data isn't communicated adequately to them, right? Foster a data culture that emphasizes precision and documentation. Automate and document your workflows. Remember that breakdowns in those workflows are a key problem here. Establish key performance indicators and set up a process of continuous improvement, right? So that you have a handful or two of quantifiable variables that give you a set or a sense of how well you're doing in the data quality front, and then commit to making that better over time. Integrate the things that you learn into standard operating procedures and training materials, and benchmark data quality across time, and communicate this to all your staff. So finally, just one final slide about Technical Committee 347. We're preparing standards to enable these things at scale. Standards that will target several aspects of what I've spoken about, so as to enable people to do this at scale without having to reinvent the wheel. Standards being, after all, recipes for reality, right? Most of the work in this technical committee happens online. If you understand some aspect of the agri-food systems domain, or you're a technologist that implements products or services like software for managing information systems or assets, or you're a person who helps other people implement standards, well, this technical committee is probably for you. And we have two ways of contributing to it. One is through your national standards body. If you're in Nigeria, this is SOM, and that allows you to participate directly in the work and to help vote to set your country's position with respect to these things that come up. And the other way is through a liaison organization, like, say, the Pan African Society of Agricultural Engineers or the International Society of Precision Agriculture and so forth. So please contact us. This is an email that will reach the leadership of the committee. Use our LinkedIn page as well. Subscribe to it. That'll show you things that are happening. And I will put this in the chat, by the way. And we have a main page in ISO as well, right? That you might also want to look at. We also have a YouTube channel that you can find on YouTube. Just search for ISO TC347. And you'll be able to start seeing a lot of our material there as well. With that, thank you very much. And I assume we have some questions. And I will push my other meeting back a little bit, Ibrahim, since we started a little late. So thank you.
All right. Thank you, Andres, for that. The floor is open. You can unmute yourself and put forward your questions if you have any.
Andres, yeah, thanks for walking through the, in a very practical way, and you went into the weeds a little bit, which was good as well to get an understanding of data in terms of structure, quality, and making sense of it to making it fit for purpose actually for you to make decisions. I don't know what your thoughts are on this, because you did talk about like the scalability of these principles and the approach, right? Because I'm looking at it from the lens of how most of our farmers, for example, those taking part in agriculture, are at a small, medium scale level, as we call them. And whenever you talk about technology, you talk about data, it comes across like something really out of the world, and it's expensive. So people tend to not engage, as they should. So I don't know what your thoughts are on this, because I did find it, in most of my interactions, when you talk about data and technology, people just get, well, I'll think about that later. I have other cost items that are priority right now. Yeah.
Well, the good news is I have plenty of thoughts about this, which one of which is that if you think who our customer is for most of these standards, like let's imagine that over the course of the next few years, we end up producing, I don't know, 50 standards. Okay. If that's the case, who is the user or the customer that we have in mind for those standards? Most of the time, it's going to be a technologist, somebody who's writing software or some other tool that the farmer will use, right? The use of standards isn't something that's explicitly going to be on the grower's mind, right? Maybe they'll feel especially happy someday and say, like, why am I so happy? I don't know. I'm usually so grumpy. And maybe it's because everything's working, and then that's a sense that the standards are being used. But primarily it's the tool maker that is going to be the primary user, right? And so we're mostly trying to deal with them. Now, with respect to and I said mostly, right, because there will be some standards about some processes and so forth where actually growers, maybe not necessarily the smallest growers, but certainly any advisors that work with them, would be consumers of the standard, right? But most of them would be for their technologists. Now, what kind of technology are we talking about? In many cases, the standards we're looking at will unlock being able to use people's phones, and not even necessarily smartphones, but use smart and feature phones to solve a variety of very challenging problems that farmers have now, like having better access to value-added marketing opportunities, right? Or having predictable access to crop inputs and the ability to trace some crop input coming in that's supposed to be delivered, but they, didn't know when, or they have some new pest that they've never seen before, that seems to be reproducing quickly in their fields. And, there's so many smallholders around that the likelihood that they'll be able to get their hands on an extension agent are very slim, but you could identify that with an app, and so forth, right? Those are, I think, the vast majority of the kinds of things that we're looking to do, enable through infrastructure some more tooling of that sort. Will the standards that we're making also benefit the traditional, highly mechanized, quote, rich farmer? Gosh, I hope so also, but we're definitely committed to enabling tech that can be used to make small growers' lives better. I hope that helped, Ibrahim. John.
Yeah, it does. It does. Thanks.
I have until 15 after, Ibrahim, so happy to take any other questions that you might have in mind.
Okay, I have a short one. So majority of the farmers or farming in Nigeria is done by smallholder farmers.
Yes.
So what that means is that even in terms of application of standards and supply chain issues and data gathering, it's not only siloed, it's very disproportionately done. As a country that's just setting out for formalization, what would be your quick wins? What are the low-hanging fruit we can aim for?
Okay. So TC 347 has made some assumptions about low-hanging fruit, following the advice of the ISO Strategic Advisory Group on Smart Farming. And well, one of those has to do with adopting controlled vocabularies for things, or at the very least, enabling the translation from whatever is being used in a jurisdiction to that canonical vocabulary, and from there onward to wherever you need to go, as a way of making sure that the data that you're exchanging is that its meaning is preserved and not compromised in any way, right? So that's an important early one, which is saying, hey, let's use the same codes that everybody else is. And in our case, those codes are going to be freely available on the web. So any tool maker that can just get to a GitHub repository can just pull those vocabularies every once a week or something, and synchronize and stay up to date. So that's one. Also, there's for example, our ad hoc group 9 has to do with manual field operations. For example, manual harvest, which is something that is common in smallholder farms everywhere. right? The idea being to enable creating a data model that can in turn enable making simple apps for phones or web apps or phones that can be negotiated to be put on a feature phone or what have you, that can be able to capture what you're harvesting and where you're harvesting it and who's harvesting it and when it happened and so forth, because we believe that say a bucket full of fruit with a story will hopefully get a better price in the market than a completely anonymous bucket of fruit, right? Because information is deemed valuable, and there's likely to be somebody who's willing to pay you more for that bucket if they know that that bucket came from the farm of this person that has this family and so forth, right? That brings with it a series of obligations regarding responsible innovation and a duty of loyalty and of care to that farm, right? To not like divulge where their farm is exactly, and when the harvest date is going to happen and so forth. People can go in and steal their stuff. But these kinds of projects are taking place. So going back to your question of what advice would I have for a country like Nigeria, the most important advice is get involved and make sure that this program of work gets, to representing what you need, right? So Nigeria and I think sub-Saharan Africa in general is teeming with engineers and other professionals that are eager to make a difference and to develop and apply technology, but that often have the problem that if they're reinventing the wheel from first principles, it's just too hard, right? So we seek to create a stack of standards that can set their starting place a lot further along their road so that they can focus on representing the reality of their community that they know better than anybody else with, just reusing other components for all the other stuff. So let's get Nigeria more involved and making sure that what we're producing really is fit for use, right? So that our standards have that data quality that we talked about. Did that help?
Yeah, it does. Just a quick one. We have 2 minutes since you have to go. In terms of agric retail, packaging and production of produce in Nigeria tends to be very informal, but we're getting into the age where we're exporting a lot, and we're also having a proper retail chain that takes from end to end for the produce. So for people who are coming in from that end, what's your observation or what's your view? What do they need to be aware of?
So things like what Ad Hoc Group 9 is doing are worth looking at because they enable better traceability. For the retailer of crop inputs, there's a lot of opportunity here, right? Because typically retailers worldwide are interested in being seen as trusted advisors to the farmer, because that way they can establish a relationship that establishes in turn a barrier to change, right? So if the other retailer has some crop input for a marginally lower price, you don't want your customer to run off and make purchases just based on price, because value is, a bigger umbrella than just price, right? And so I see the pattern where retailers want to establish themselves as service providers and um, and trusted advisors. And technology is a really good place to do that. So I think there's plenty of opportunity for retailers to take positions here as providers of tooling that can allow the farmers to keep better track of what they're doing and if they're making money, if they're not making money, to sell better and so forth. Not the only people, of course. Um, Crop advisors or people who would like to be contractors and do the data management for farmers can look at our standards as ways of increasing their efficiency because, for example, they don't have to spend so much of their time just converting data formats, which is a soul crushing way to spend one's time as a service provider in agriculture. And then, hopefully that means that the per hectare costs of providing their services drops, and then their services become available to smaller farmers, right? So that is all part of the vision that we're pursuing in Technical Committee 347.
All right. Thank you, Andres. Thank you, everybody on the call. Do we have any more questions?
Well, yeah, just a quick one, just on the back of traceability, because that's one area that I'm quite interested in. Because we do have an issue of quality of food safety concerns. So if there's an outbreak of a disease right now in the value chain, because we don't even collect data to start with, the culture is out of the window. It's difficult to actually trace it from source and to deal with it. So I recall speaking to a technical partner, we're looking at the use of the blockchain technology. And for that, is that something that has come through in some of your findings and discussions around?
Blockchain is one of those things that that people are excited about. But I don't think that blockchain addresses the root causes of any of these problems, right? So blockchain is a technology for keeping ledgers of pretty disciplined data and that has a moderate volume and a consistent record length in a context of very low trust, right? Agriculture, to start with, is built on relationships of trust. First thing. Second thing, the data is pretty wild and is often, very different sizes. And in many cases, the data sets are huge, right? But ultimately, right, the problem here is that blockchain is an elegant way of packaging data and making it immutable when you move it from point A to point B. That's not really our problem. Our problem is that the data is bad to begin with, right? So you can put a package of, take a rotten apple and you package it in, the most beautiful silk wrapper, right? And you send it to your friend. Your friend is still going to find a rotten apple, right? So I don't think that we should focus on the wrapper. We should focus on the apple. So what are the processes we need to put in place to make the data quality in our systems better to support that traceability, right? The mechanisms that data processing have afforded us over the last many years, like client server architectures and uh, um, and service-based architecture and microservices and so forth are just fine for taking data from a phone and taking it to the cloud and then taking it to some other step, right? That wheel is already invented. It works great. Our problem is that And of course, there's all kinds of, elegant cryptography and good ways of storing data that already exist. Our problem is primarily that our workflows are so bad and so poorly documented, and the role of and value of data quality is so poorly understood in our industry that the apple's always rotten to begin with. The data apple, right?
Thank you.
Does that make sense?
Yeah, it does a lot.